Good morning, children. Today in surface areas and volumes part 2 we are going to continue with the exercise problems. Exercise 13.1 continued. Question number 4. A cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. You are given a cubical block of side 7 cm. When we are fixing a hemisphere on the top face, we can see the possible diameter for the hemisphere. The greatest possible diameter will be equal to the side of the cube. And we can say diameter of the hemisphere will be 7 cm and radius is equal to 7 by 2, which is equal to 3.5 cm. To find the total surface area of the solid, we can see it will be total surface area of the cube plus CSA of the hemisphere minus area of the base of the hemisphere. TSA of the cube, we know it is 6a square. CSA of the hemisphere is 2 pi r square and area of the base of the hemisphere is pi r square. So finally we can write it as 6a square plus pi r square. Substituting the values, we can see it will be 6 into 7 square, which is the side of the cube, plus 22 by 7 into 7 by 2 whole square, which is equal to 6 into 49 plus 77 by 2, which is equal to 294 plus 38.5, and the final answer is 332.5 centimeter square. Question number 5. A hemispherical depression is cut out from one face of the wooden block such that diameter L of the hemisphere is equal to edge of the cube. Determine the surface area of the remaining solid. You are given from a cubical block a hemispherical depression is cut out and it is given diameter of the hemisphere is equal to L, which is same as the edge of the cube. So we can say diameter of the hemisphere is the same as side of the cube, which is equal to L. Therefore radius is equal to L by 2. To find the surface area of the remaining solid, it will be total surface area of the cube plus CSA of the hemisphere minus area of the base of hemisphere. Again it will be 6a square plus 2 pi r square minus pi r square, which is equal to 6a square plus pi r square. Substituting the value for side as L and radius as L by 2, we can see it will be 6L square plus 22 by 28 L square, and by taking common factor L square, it is 6 plus pi by 4 into L square. Question number 6. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. We are given the capsule is in the shape of a cylinder and two hemispheres stuck onto both ends. And it is given diameter of the capsule is 5 mm. So we can say diameter of the hemisphere as well as diameter of the cylinder will be 5 mm. So radius will be 5 by 2 equal to 2.5 mm. Now we are given the length of the entire capsule is 14 mm. The length of the entire capsule can be taken as height of the hemisphere plus height of the cylinder plus again height of the second hemisphere, which is equal to 40. Therefore, height of the cylinder will be 14 minus 2.5 minus 2.5, which is equal to 14 minus 5 equal to 9 mm. To find the surface area of the capsule, it will be CSA of the cylinder plus 2 times CSA of the hemisphere. CSA of the cylinder is 2 pi RH and 2 into 2 pi r square, which is 2 times CSA of hemisphere. Taking common factor 2 pi r, it will be 2 pi r into h plus 2r. Substituting the values, radius is equal to 2.5, height of the cylinder as 9. Our answer will be 2 into 22 by 7 into 5 by 2 into 9 plus 2 into 2.5. Final answer is 220 millimeter square. Question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also, find the cost of the canvas of the tent at the rate of rupees 500 per meter square. We can see the tent is made with a cylinder and a cone on the top of it. It is given height and diameter of the cylindrical part are 2.1 meter and 4 meter. Therefore, we can write with cylinder diameter is equal to 4 meter, which gives radius is equal to 2 meter. Height is also given 2.1 meter. For a cone, slant height is equal to 2.8 meter. Radius of the cylinder and cone remains the same. Therefore, radius of the cone is equal to 2 meter. To find the area of canvas used for making the tent, we just want to add the CSA of the cylinder plus CSA of the cone. Base area is to be avoided as we will not use canvas on the floor. So, it will be 2 pi RH plus pi RL, which is equal to pi r into 2h plus L. Substituting the value, radius is equal to 2 meter, height of the cylinder equal to 2.1 meter, slant height of the cone as 2.8 meter. Our answer will be 22 by 7 into 2 into 2 into 2.1 plus 2.8, and the answer will be 44 meter square. To find the cost of the canvas at the rate of rupees 500 per meter square, we can write cost of 44 meter square of canvas will be 500 into 44 is equal to 22,000 rupees. Question number 8. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. We can see a solid cylinder of height 2.4 centimeter and diameter 1.4 centimeter. So, the radius of the cylinder will be 0.7 centimeter. It is given a conical cavity of the same height and same diameter is removed. So, radius of the cone will be 0.7 and height of the cone will be 2.4 centimeter. We can use the slant height L is equal to square root of h square plus r square, which is equal to square root of 2.4 square plus 0.7 square, which is equal to square root of 5.76 plus 0.49, and the answer will be 2.5 centimeter. To find the total surface area of the remaining solid, we can see it will be CSA of the cylinder plus base area of the cylinder and the CSA of the cone, which is equal to 2 pi RH plus pi RL plus pi r square. Taking pi r as a common factor, we can see it will be pi r into 2h plus L plus r. Substituting the values, we can find 22 by 7 into 0.7 multiplied with 2 into 2.4 plus 2.5 plus 0.7, and the final answer will be 17.6. To find it into the nearest centimeter square, we can round it as 18 centimeter square. Question number 9. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. If the height of the cylinder is 10 centimeter and its base is of radius 3.5 centimeter, find the total surface area of the article. We can see the cylinder is a solid cylinder, and from both ends 2 hemispheres are removed. We are given height of the cylinder is equal to 10 centimeter, radius of the cylinder is equal to 3.5 centimeter. Therefore, radius of the hemisphere is also 3.5 centimeter. The total surface area of the article will be CSA of the cylinder plus CSA of the first hemisphere plus CSA of the second hemisphere, which can be written as CSA of the cylinder plus 2 times CSA of hemisphere, which is equal to 2 pi RH plus 2 into 2 pi r square. Taking 2 pi r as common, it will be 2 pi r into h plus 2r. Substituting the values for h is equal to 10 centimeter and radius is equal to 3.5 centimeter, answer will be 2 into 22 by 7 into 3.5 into 10 plus 2 into 3.5, which is 2 into 22 into 0.5 multiplied with 10 plus 7, and the answer will be 374 centimeter square.